video, we are going to be talking about inverse functions. So as you look at the objectives, the first thing we're going to talk about is finding the inverse of a function and then using the horizontal line test to determine if the function that's graphed currently has an inverse. And then ultimately, once we're given a graph, how do we graph its inverse? So to find an inverse is basically just a two-step process. First, you're just going to interchange x and y, basically replacing the x with the y and the y with the x, and then solve for y. So let's take a look at a few examples. Here you will see that f of x is basically the same thing as y, so that's what I'm going to go ahead and do, right? Y equals 7x minus 5. Now that first step was to replace the y value with x and the x variable with y. So now I have a new equation that says x equals 7y minus 5. I'm going to solve for y, so I'm going to get y by itself by adding 5. And then dividing by 7. So my inverse function is x plus 5 divided by 7. Let's try another example. Again, I'm going to replace f of x with y. And now the first step is going to interchange x and y. So changing that y to say x and that x to say y. Again, you're going to solve for y, so getting y by itself. So first thing to do is subtract 1. And now we have to remember, how do we get rid of a cubed exponent? You got to take the cube root of both sides. So my inverse function is going to say the cube root of x minus 1. Now there's just one more example that I'd like to show you. Again, changing that f of x to say y. Recalling that you need to switch the y with x and switching the x with y. Solve for y, so the first thing I'm going to do is add 5 to both sides. And then at this point, you would undo that division by multiplying by y. But I'm not actually going to distribute that y on the left-hand side. I'm just going to leave it as is. So to get y by itself, though, I'm going to divide by x plus 5. So y is all by itself on the left. And now I have 3 divided by x plus 5. So my inverse function is going to say 3 divided by x plus 5. The horizontal line test for inverse functions. A function f has an inverse, that is a function f of -1 is the notation that is used if there is no horizontal line that intersects the graph of the function f at more than one point. So if you take a look at this parabola right here, an inverse of a parabola is the square root function. However, the square root or the sleeping parabola is not a function because of this horizontal line intersects my graph at 2 spots. Now really I could draw a horizontal line anywhere, and as long as it hits my graph more than once, my inverse is not a function. So the horizontal line tells you if the inverse is going to be a function or not. So again, take a look at these four examples. Which of the following graphs represent functions that have inverse functions? So basically what I'm asking you to do is take a look at these four and determine through a horizontal line test whether or not the inverse is a function. All right, you should know that A is a function and the inverse is going to be a function. B is a function, but the inverse is not. And the reason why is if I draw a horizontal line, there is a spot where I hit the graph twice. Again, C is no, because if I draw a horizontal line here, I hit my graph 3 times. But then D is going to be a function along with its inverse, because every horizontal line I draw is only going to touch my graph once. Now, when you are graphing an inverse, here are just 2 examples. The one on the left is y equals x cubed and the cube root of x. And the one on the right is y equals 2 to the x and then log of x. Okay, so those are inverses of each other. Now what you can see is this green dotted line. Now the green dotted line in both graphs show the equation y equals x. Now that's the line that you are going to use to help you graph an inverse, because what happens is you're going to reflect over that line in order to graph the inverse. So let's take an example. Pause the video right now and copy down this graph, y equals x squared, highlighting a few points. Now we know that the inverse is not a function because of the horizontal line test, but we can still graph it anyways. Now what's going to happen is we are going to reflect my blue parabola over the line y equals x. Now what happens when we do this is we're basically going to flip-flop the x and the y coordinates of these key points. So when I flip-flop 0, 0, that's just going to stay 0, 0. When I flip-flop 1, 1, it's just going to stay 1, 1. But now, when I flip-flop negative 1, 1, it's going to become 1, negative 1. So notice the x and the y values of that coordinate changed places. They flip-flopped. Just like when we solve for the inverse, we interchange the x and the y values. Same thing here when we go to graph. So when I graph the point 2, 4, reflecting it over the y equals x line, I'm going to switch my x and y value. So therefore it's going to become the point 4, 2. When I flip-flop the point negative 2, 4, it's going to become 4, negative 2. Then we can go ahead and graph our sleeping parabola. Okay. Now again, this is not a function because it did not pass the horizontal line test, and the red graph would not pass the vertical line test either. Here's another example. Okay. Now this is the point y equals x cubed minus 2. I'm just going to zoom out so you can get a better picture. Maybe even a little bit more. So that way you can see some key points. Now here we have the point 0, negative 2. We have the point right here, 1, 0. This one right here is negative 1, negative 4. And we're going to use those 3 points to help us graph the inverse. You can see again that I graphed the line y equals x. So hopefully you've plotted these points on your graph, because now you're going to graph the inverse. When graphing the inverse, remember that we flip-flop our x and y values at each point. So let's start with the one here on the left, -1, -4. When I switch places, I end up with the point -4, -1. So right here in purple. When I switch the point 0, -2, it becomes -2, 0. When I change the point 1, 0, it's going to become the point 0, 1. Now go ahead and graph our cubic function with a horizontal shift of -2. Okay, shifting it to the left 2 units. Now pause the video at this time and answer the following multiple choice question. Find an equation for f inverse given that f of x equals 4x minus 2. 4x minus 5 divided by 2. You will see the answer worked out for you. And you'll notice that the correct answer is C. Find an equation for f inverse given that f of x equals x minus 3, that quantity cubed. Pause the video, work out your answer. Again, you will see the answer worked out for you. So in case you made a mistake, you can look back and find your error. You'll notice that the correct answer is A, and in this problem, you need to be extremely careful with how long you make your radical symbol. Okay, the radical symbol is the one that looks like the square root, and notice here, if I were to have extended it over the +3, that's actually showing a different problem or different equation than the one given. Go ahead and delete that for you. Now that is the end of the inverse video. You will find your homework assignment on Classroom. If you have any questions, please make sure you raise your hand and I will come over and help.